So in the previous examples, we learned how to use GeoGebra to find the probabilities with the normal distribution. Now we're going to look at a quick way that we can make estimations. It's pretty accurate, but it's truly just an estimate. And this is called the empirical rule. Now, this rule only works with the normal distribution, so you can't use this with the binomial distribution. So the empirical rule says that if you look within one standard deviation of the mean, approximately 68% of the data falls within one standard deviation. So this is your 68%. Now we split it so that we can see how much is from 0 to 1 and how much is from -1 to 0. So we took the 68% and we split that into 2. So from here to here is 34%, and from here to here is 34%. Now, if we go within 2 standard deviations and we go out further, that contains about 95% of the data. So from about here to here, within 2 standard deviations, that's 95% of the data. Now, when we split that up, it's 13.5 from -2 to -1. And then from +1 to +2 is 13.5%. And then when you add that in with the 34 and the 34, that gives us a total of 95 from -2 to +2. If you go out another standard deviation in either direction, so out this way, that is 99.7% of the data. And then when you split it up from here to here, from -3 to 2 is 2.35%. And from 2 to 3 is 2.35%. So when you add up all of those areas between -3 and +3, you get that 99.7. Now, there's still some left over in these tiny little wings here. Remember, it has to add up to 100%. So there's still 0.3% left over. And when we split that up into these tiny little wings on each side, that's 0.15% in each of those wings. So we can use this as quick estimates. Looking at example 6, it says IQ scores are normally distributed with a mean of 100 and a standard deviation of 15. So here's our graph. 100 is going to be in the middle, and we're going to go out 3 standard deviations in either direction. And since we have a standard deviation of 15, this is going to be 115. 130, 145, and then going in the other direction, this is going to be 85, 70, and 55. Now, making our little areas for the empirical rule, I know that each of these wings, that's 0.15%. I know between these two values is 2.35%. And then this is 13.5%. And then this is 34% and 34%. So we've got our picture drawn. Now, the question asks us in part A, estimate the percentage of people with IQ scores above 130. So looking at above 130, that's all of this area in here. So we want to add up 2.35 and 0.15, and that's going to give us an approximate of 2.5%. and that's an approximate of 2.5% of people that have IQ scores above 130. Now, for part B, it says, using the empirical rule, estimate the percentage of people with IQ scores between 85 and 115. So let's use a different color. So between 85 and 115, that's here and here. So that's 34 and 34. So that gives us an approximate percentage of 68% of people that have IQ scores between 85 and 115. Example 7 says a factory produces a large number of candy bars each day. The weight of each candy bar is normally distributed with a mean of 50 and a standard deviation of 2. The weight of the candy bar should be between 48 and 52 grams. If a candy bar is too light or too heavy, it is considered to be defective and discarded. So let's draw our normal distribution so that we can make our chart. Okay, 50 is in the middle. Our standard deviation is 2. So this is going to be 52, 54, 56. And we have 48, 46, 44. Let's draw our areas. So this is 0.15%, 2.35%, 13.5%, 34, 34, 13.5, 2.35, and then our last bit on the other side, 0.15%. Now let's use this chart to answer our questions. It says, what is the probability that a randomly selected candy bar will be sold? Meaning it's not going to be discarded. So we're looking at anything that's between 48 and 52. That's what it tells us in here, that's what's considered the normal weight. Anything outside that gets discarded. So our answer for this, if we take 34 and 34, that's 68%. Now, what is the probability that a randomly selected candy bar will be discarded? If 68% are kept, then we can figure out the complement of that by doing 1 minus 0.68, and that's going to give us 0.32. The other way that we could do it is just add up all the other bars. So if I add up 13.5, 2.35, and 0.15, and then added up all these on the other sides, those are when it's outside the normal range. If we added up all of those percentages in green, we would get 32%. Okay, last example, the number of goals scored per season by players in a professional hockey league follows a normal distribution with a mean of 22 goals and a standard deviation of 6 goals. So let's draw the graph. So the center is going to be 22. I want to give myself some more room. So the center is 22. And our standard deviation is 6, so this is going to be 28, 34, and 40. And then when we go 6 in the other direction, that's going to give us 16, 10, and 4. So let's make our areas. So our two little wings on each side, that's 0.15. Then this is 0.235. Then this is 13.5. And then 34 for each of these. Using the empirical rule, what is the approximate probability that a player scores between 10 and 28 goals? So we're looking between 10 and 28. So we want to add up all of these areas. So we're going to add up 13.5, 34, and 34. That's going to give us 81.5%. Now, what is the approximate probability that a player scores between 2 standard deviations below the mean and 1 standard deviation above the mean? So if we go 2 standard deviations below the mean, I'm coming over 1, 2, and then I go 1 standard deviation above the mean, that's going to give us the same value. We're just repeating the question in a different way. It's still all of this area. So our answer for that is going to be 81.5%.